this unit that had bivariate categorical data.
2 units. Explanatory and response variable.
Not the unit we're wrapping up and testing on tomorrow. Some other ideas. Say again. Okay, so remember the unit that we're wrapping up, the segmented bar graph and the mosaic plot were bivariate data. Okay, so what else was connected to the segmented bar graph and the mosaic plot? There's some types of relative frequencies. Marginal, conditional, and joint relative frequency. So I say all that to say that will not be a part of a free response. I'm not saying it won't be a part of a multiple choice question, but there are some AP classroom progress check questions that go with those ideas, so I'm going to let that be a part of the next test. Okay, it is bivariate data, it's just categorical, not quantitative. They just had that in mathematics, so I'm probably going to switch that order with future times on the test. That somewhat reduces the cognitive load of the test. That's why I bring that up, right? So you don't have to stress about that, those details for this test. Up here though, number 5, the reason I started thinking about that is percentile, right? We got to go back to the things we've talked about this year. This is not what was asked about over there, but how would I interpret this 20th percentile?
20% are as below.
Okay.
Value less than or equal to 12 places.
So say it one more time.
20% of homes in Atlanta have a value less than or equal to 12. I don't know how to read.
120,000. Yeah. So homes. Yeah, I would start with that 20%. I think there's a slightly different way they had us interpreted in the lesson way back then, but you could very easily say 20% of all homes in Atlanta, Georgia have a value of 120,000 or less. Remember, a percentile is the percent. It is cumulative, but it's the percent. There's a word I'm looking for. Starts with an A.
An area.
Not above.
At.
It's percent at or below. Don't forget, a percentile is a percent at or below, okay? So the big thing with that is, I saw a lot of it. Ooh, I need to pass back fair models. Don't let me forget that. Actually, can you go ahead and do that? While I'm talking, they're in the back. I also have some other stuff to hand out to you, but the ones that are written on. First, I have to say, Andrew, I'm so sorry I dropped yours, and when I went to pick it up, it slightly ripped. Just a little bit. It is important though, when you learn from this. I do have extras, some blank ones of that, because there are some of us that need to add some more for sure. So if you're looking at yours and you're like, man, Mr. Kenny said I need to add more, then let me know and I can give you a blank one so that you can add some more, because there's a lot of important stuff. But I bring that up because I saw some of us write on our Frere models, hey, percentiles, so percent at or below, but then we missed that on the DYU when we said it was okay for it to be in, right? Percentiles are never in a thing, it's at or below. Huh? It's a location, right? A percentile is a location, okay? So calculate and interpret a z-score. I'm going to skip that. Is it reasonable to assume that the distribution of Atlanta homes is approximately normal? Okay? Any ideas on this 5C? Because I can tell you this, I know the answer right away. And the answer is no. Anyone know why?
Because it's way.
It's
You can't really get paid for it.
51%.
Okay, so one, you can't have a negative amount for a house, right? There's that detail. In general, houses are always skewed right. That's not something you would know. I only know that because I've done so much with statistics. But here's how I do this one. Right here. 386,122. If it was normal, and that was my mean, one standard deviation was how much? 2,221. So 165, 122. Anyone start to see an issue right away?
Wait a second.
I'm gonna get into the negatives at 2 standard deviations. Is that possible?
No.
No. So it can't be normal. It's gotta be skewed right. Like the reason why that standard deviation is so large is because what it really looks like is something like this, right?
Right.
That mean was here and the standard deviation was increased significantly. But if I talk about a normal distribution, it has to have roughly how many standard deviations on each side? 3, right?
Yes.
If you can't have 3 standard deviations on each side and it doesn't follow the empirical rule, it's not normal. Okay? So, not normal, not 3 standard deviations below the mean. So that's something that we want to make sure we hold on to. That's important. If you cannot follow the empirical rule, which you can't if you can't get 3 standard deviations below and above, it can't be normal. Ryan, does that answer your question?
Yeah.
Everyone
What I
else?
was confused about the key answer was, if the distribution of the home values are approximately normal, only 11.51 of homes would be a value less than or equal to the small home value.
I'd have to look at that. I hate that in explanation. This makes way more sense. At least to me. Like, both of those would provide evidence. I don't know how they're getting. Oh, 11.5%
Yeah.
is what it says.
11.5.
11.5%. Yeah. So is less than what?
Is
The 120.
homes.
The 120?
Yeah.
Yes.
Oh, okay. So the 120 would be here, right? You convert that to a z-score minus. What was that z-score, by the way? Did you calculate that, Raina?
Minus 1.2 over 2 was from B.
Negative 1.20.
Oh,
Zero.
4.2.
Okay, let's go to 0. So when I look at that, I could find the area to the left, right?
Yes.
So what they're saying is the area to the left would be 11.2%. Is that what you said, 11.5?
5, 1,
Okay.
yeah.
So if it was a normal distribution, 11.5% of homes would be at or below. But what percentile is it actually at? The 20th percentile. You see how that doesn't follow the empirical rule at all? It doesn't. So like, it is at the 20th percentile, but if it was a normal distribution, it would be at the 11th percentile. Those are not the same, so it can't be normal.
How do you know the difference of it? We got,
Well, they told us the 20th up here.
yeah.
And if this was a normal distribution, and I calculate this z-score, and I find the percent at or below, it's 11th percentile, okay? So I found that area, the area I guess would be 0.115.
Yes.
So if it was normal, it'd be at the 11th percentile. It's not. Those don't match up, so it can't be normal.
So this kind of problem, what should we focus on to
Either would be perfectly acceptable.
do yours answer and the answer?
Either one, yeah. Because remember, if it's approximately normal, I focused on the fact that it needs 3 standard deviations to each side, but it also needs to follow the empirical rule. It needs to follow those percentages, right? Those percentiles. So either one would be perfect justification. Okay? All right. Free response question. Hopefully you looked at the answer key, the scoring guidelines. Were there any from the one from 2010 Form B that you have questions about? Also, Madeline, was I able to answer your question that you sent me last night? Kind of.
Like, is 225 and 275 the actual numbers or?
It's not the actual number. It's a good approximation. It's a better approximation than what they had.
So it's a
Yeah, it'd be fine.
Okay. I'm trying to figure out, did I put the wrong
No,
answer
no, no, no.
and it just happened?
Theirs is not a particularly good estimate for the median. But they were saying it could be anything from there to there. Okay, yes.
For part C,
Okay?
Is there,
Oh, I should probably pull up the,
all it says is the values, but can you like list another characteristic?
hold on 1 second, sorry, I just realized I don't have the actual problem in the slides. And I should probably pull that question up, shouldn't I?
Now.
Alright, this is 2010 Form B, right? Nope, that's the scoring guideline, that's not the one I want. I know, I'm sorry. Alright, here we go. There we go. Alright, you said C?
Yeah, like, is there any other way that like, you could like list another characteristic, or can it only be?
I mean, so, well, it needs to be, we're comparing river X, right, to, was it a stem plot? So we have to compare it to the stem plot. And I guess having the scoring guidelines not a bad idea anymore. So here's the stem plot that we should have had, okay? With that stem plot, that you can totally see and totally have, so please do know you need a key if you ever make a stem plot. What can you, yeah, no comments, what do you see in that stem plot that should jump out at you? I see a gap, I see clusters, either way would be perfectly acceptable to talk about it, right? There's a gap in the data from 56 to 73, right? Can you see that in this box plot here?
No.
No, right? All I see in the box plot is that it's slightly skewed right or skewed right. Okay, so the only thing that you could talk about and see when it says describe a characteristic of the distribution that can be seen in the stem plot but not seen in the box plot. When we talk about a characteristic of a distribution, we're talking about cussing in context, right? That's analyzing the distribution. So the center, right? They kind of are both the same roughly in the box plot and the stem plot. The shape and the spread are roughly the same, but the gap, I cannot see that in a box plot. Does that answer the question? Wait, that was your question, okay? Was that also your question? You had your hand up.
It wasn't, but like,
Okay.
oh, I had like a question for like on here, like on scoring, it like had 6 by itself. So like when we, I don't know how to explain
When it had
that.
6 by itself, what do you mean?
Like we, like
For
that
which
gap,
part?
that gap on part B.
Okay.
So, so when it doesn't have like on here, like we didn't have that value percentage, but we still add it because we're jumping from.
Oh, I see what you're saying. So you're talking about when you construct that stem plot, yeah, you
Yeah.
can't skip stuff.
Okay.
Yeah, you can't be like, oh, there's no 60s, I'm gonna go from 5 to 7. Like, do you, does that, like, if you were to make a graph, do you skip the 6?
No.
Okay, same thing. So that's a good question, I'm glad that you asked that. Yeah, no, you cannot skip that 6, right now.
And C, what I just did was in Boxer, you can see the mode of the graph, would it still count as partial spread, or would, I know I missed a key point.
I don't, so let's see, what does the rubric say? Let's see. You have to include a recognition of the gap in the stem plot and give an indication of where the gap occurs. Or if the response comments on bimodality, which you can't see. Notice the rubric says, yeah, partially correct, you have to see the gap or the bimodality. Because I will say this, you actually don't really see the mode. You may see a peak. Whoops, not that. You don't see a so when you look at this, you don't easily see the mode. Because all of those 40s are grouped together, right? So that's not the mode. I guess 46 could be a mode, 46 or 53, but I will also point out, have I ever talked about modes in class?
No.
Don't talk about mode. Mean or median. Those are the measures of
What
center.
what I was talking about was, either this reason or I talked about that.
I see what you're saying. They may accept that, but, so yeah. And they talk about the shape, don't they?
Yeah, it says something about.
Yeah.
Yeah, partially.
Comments on bimodality, yeah, and talks, but so notice you have to talk about where those clusters are as well. So that would be a peak. So I see what you're saying. So bimodal, not the mode, but those peaks, yes. Then you need to talk about where those peaks are located, those clusters. Yes, Sophie.
I know it says gives an indication of where the gap occurs to, but you have to like say 6 within the same thing.
be careful, it's not, well, oh yeah, so it's not 60, it's what,
Like
6,
Like,
that's right, because it's parts per million. So I would say from like 5.7 to 7.2, saying there's no data between that 5.7 and 7.2. So if you look at, yeah, right, okay, and say they did 5.6 to 7.3. The sim plot shows a gap in the distribution between these values. That gap is not inherent on the box plot. Okay? Does that make sense? Yes, Raina?
In rate, in A, can you go over what exactly would they mean by concentration? Because when I looked at the,
That's the context.
just context,
Yeah, look at the context of this problem. Right, yeah, it's the concentration of
I don't know if
Aldrin.
I'm full credit because I just cuss it.
You gotta cuss in context, like, what is, so what are we analyzing, was it X or?
All of them.
Oh, compare the distributions, right, so the median concentration of Aldrin, notice I'm just looking at that x-axis. So the median concentration of Aldrin in parts per million is the highest, maybe about 5.3. Then River Y has the next highest with about 5 parts per million, and River Z has the smallest, about 4.4 parts per million.
Yesterday we like pointed out like if you know like the highest and then the lowest, like do we still have to do that now?
It's a fantastic question. My guess, my prediction, I think is no. I haven't scored one specifically on the AP exam that has that. Let's look at what their rubric says in a second. But notice, yeah, just have to make sure you accurately compare. So I would
Yeah.
think saying what the highest and what the lowest is would be enough.
Okay, yeah.
River X has the largest spread, or the largest range
Mhm.
in concentrations of Aldrin parts per million, then River Y, and then River Z. River X is skewed right. River Y is approximately symmetric, and River Z is skewed left. Notice I'm directly comparing those things.
Can you go over, like, in the rubric where it says that about 50% of the concentrations of Aldrin for rivers X and Y are higher than all the concentrations for River Z?
Yeah, I don't particularly love that. So notice that's the like idealized answer that the chief reader came up with. That's actually how that happens. Notice it says essentially correct if the response correctly describes in context, center spread, and shape, and makes a comparative statement involving all three for at least one characteristic, right? So partially correct. Okay, so you just had to mention all three distributions at some point, but it probably would be safest to go ahead and do X, Y, and Z. Like compare all three. I think there's an implication that would be strong enough for the AP exam. If you just said what's the highest and what's the lowest. So here's what they're saying, to answer your question, Ian. There's my 50th percentile, right? There's my 50th percentile. So half of the data is higher than even the maximum for River Z.
Okay.
Would I ever talk about that? No. Is that a good thing to note? Sure, but that's not usually the way the AP exam scores, and you didn't have to mention it that way to score an E there.
So when you say times concentration of, rather than just saying River X has the largest median and River Z has the smallest median.
Right, because you just saying that they have the largest median or smallest median what? You have to talk about, that's the context, right? The context is the concentration of Aldrin in parts per million for rivers X, Y, and Z. Read through that blurb at the top to know what the context is about. Also look at the labels for those axes. Madeline, it looks like you were about to ask a question.
On the A, so
Yep.
yesterday, I think I compared them, but I didn't put any numbers. And
Yeah.
so I technically didn't get the cuts right because like, there just wasn't.
Was that the 2019 one? No. You talking about the one we did in class?
20
Yeah,
seconds.
one of them, so then the one that I did for 2010, like, yeah, then I put like a lot of numbers, but I only compared one of them, I think.
Well, and notice that it literally says, that's the P. It literally says right here that you need to correctly describe all three characteristics and make a comparative statement involving all three distributions for at least one characteristic, specific numerical values are not required. However, they are not always consistent on that detail. So to be safe, go ahead and include numerical values at least once, I would say. Notice I said at least once. So I only concentrate on the median. Typically that's the thing where it's like I needed at least one of them, and the median was easy to identify. But overall, yes, you just need to make a comparative statement. Which one's the greatest? What's the next greatest? What's the next smallest? I will say, just looking there, Emerson, if you directly control the settings here, that's going to make it way easier where you put in your minimum and maximum. Sorry, so I'm trying to do normal distribution stuff. All right, final questions. We got to get moving on bivariate data though. So this makes sense. Do you understand how to do this a little bit better? Okay. One final note I will make is I said there will not be bivariate categorical data, but there will be bar charts and bar graphs, just not segmented ones, not mosaic plots. I just wanted to make sure that's clear. Like displaying categorical data, pie charts, that kind of stuff can definitely be on your test. Right?
Are we for fair models, can we be submitted tomorrow?
Okay. Alrighty. Oh yeah, I did update this. Alright, so we're just going to do a quick little recap of scatter plots that we hit yesterday. Correlation R and least squares regression line, that's what we're going to get to today, which is why you need a calculator with a hat on it. There was something I was saying about earlier when I heard people coming in. I heard one person say the thing that they're capable of was, I can't remember exactly what it was, but I was really happy with the way it was said. He just assumes it was him. It was something about not getting down or not getting frustrated. The idea of like staying positive. Remember, huh? That one, yeah, not giving up. That's a hard thing to do sometimes, right? It's super easy to give up. So I want to emphasize and I want to applaud that. Like, guys, you're all capable of amazing things. Don't give up. Work with me, and I'll work with you, and I'll get you there. You're capable of amazing things. Don't forget that. I forgot to take that out. Okay, so actually, I forgot to put something in. Mr. Anderson, can you do the Frere models, and I'll do the proficiency scales?
But he has candy.
Sure. Did you say, but I have candy? I do have candy. Man, Emerson. You want to struggle. Okay. So, I've never actually done proficiency scales for this unit because I've always done this unit at the end of the course, or at least for the last few years when I've started proficiency scales. So I had to make a whole new proficiency scale today, so I'm a little behind on a couple of things. But, there's your proficiency scale. That's the stuff we got to learn through this unit. I think I did a good job. This is, okay, so, hey guys, please hear me clearly, okay? I want to make this very clear. This is Unit 3 for us, the bivariate data stuff, that's why it's not on your test, it's Unit 3 for us. It is Unit 2 for the AP Statistics course of study, okay? Because remember, we started with creating studies or collecting data, which was Unit 3. Then we went to their Unit 2, or their Unit 1, and now their Unit 2. So from here on afterwards, we will be same units as them. That's part of the reason why I did bivariate data here as well. Makes things a little bit easier. So notice what I was talking about earlier, two-way tables, all the way to mosaic plots, like that's stuff we've already covered. You got to know this, okay? Hopefully we're looking at some of this foundation and some of it looks familiar, like explanatory variables, response variables, scatter plots, outliers. Now we're going to learn about a new type-ish of outliers today. Linear versus nonlinear, standard deviation. We're going to learn about a new standard deviation that deals with the type of data we're looking at. It actually helps things make a lot of sense in some cases. And so down here is hopefully a lot of foundations that you're like, oh yeah, I know how to do that stuff. Trend lines, regression lines, does that sound familiar? Have we ever done that before?
Yeah, well, I've heard of it.
You've heard of it? Not really? Not sure? Okay. So, I'll talk briefly about it later. We're going to find out a really important type of trend line soon. So, you'll notice up here, like just looking at target, direction, unusual features, form, and strength. Does that sound familiar at all?
Yeah.
That's our DUFs, right? So remember when we analyze one variable data, we need to use what acronym? CUS.
Wait, cut.
Remember, when you have one variable data, CUS that data. Center, unusual aspects, shape, and spread. When it's bivariate like this though, we gotta use DUFs. We gotta look at the direction, we gotta look at unusual features, the form, and the strength, okay? So we're gonna recap just a little bit, but we're mostly gonna move into this stuff here, talking about correlation, coefficient of determination, least squares regression line. That's the focus of this unit. Let's grab some candy. That was yesterday. Okay, so scatter plots, quick notes, okay? So I just want to reestablish this. When we got to here, scatter plot, it's this thing. What goes along the x-axis? Explanatory variable, right? So whatever we think explains something else. Here along the y is my response variable. And does a graph like this right away, does that show that there's causation?
No.
What does that show? Correlation and correlation only, right? What do I have to have in order to establish causation?
Nice treatment.
Treatments in an
That's not an experiment.
experiment where we have reduced our confounding, right? So we got to reduce confounding. I always want to do that review. All right, finally. So if we're going to analyze a distribution, we need to look at DUFs. So what was D again? Direction. And when we say direction, what do we mean? So you can say positive or negative. The other way you can say that is increasing or decreasing. Okay? So when we say that there's a positive, and I bring this up because this came up on an AP exam a few years ago, where they said, hey, this has a positive, weak, linear relationship. What do they mean by positive? And kids were like, positive relationship just means that it's overall increasing, right? That's all that means. So as the independent variable or explanatory variable increases, the response variable increases. Unusual features or aspects, is that what I said yesterday? Okay, either one. I think the book / mathematics has features, so I started doing that. So what unusual features do you think we might be referring to?
That is not in following the lines.
So something that is not following the lines,
Outliers.
so those would be called outliers. And there's actually two different types of outliers that we'll talk about. Fun fact for you though, bivariate data, we never get into the weeds of how to determine if it's actually an outlier. We just call it no, not an outlier, a potential outlier, yes. Okay, so we don't get into the weeds of is it an outlier or not, it's just a potential. And gaps, right, or clusters of data. I think there's something I'm missing from that actually. Let me check.
Who's running for grade club?
Who's trying to learn stats right now? Oh no, it's clusters. Okay, so gaps are clusters of data. Okay. So gaps meaning that there would be clusters. So instead of being continuous like this, or not continuous, but set of data here and a set of data here, right? So if there's clusters of data points, that's something to be on the lookout for. All right, F. Form. And there's actually technically like a lot of different forms, but the only two we care about, linear versus nonlinear. Okay. And last one is strength. And technically, I think mathematics talks about 4 different strengths. I don't. I'm going to focus on just 3. I'm going to focus on a weak / no association. So that's technically one. Either there's a weak association or no association. You can have a moderately strong or a strong association. Okay? And you go, Mr. Kenny, how do I know if it's weak or moderately strong or strong? Guess what?
There's no association.
That's the next lesson.
That was about
I got you.
Mr. Kenny,
Yeah.
it's not a good time to tell you that like I like lost the packet. I don't know where it is.
Dog, seriously? It was yesterday.
I don't know what happened to it.
No, it's not a good time, but I think, do you remember where the originals went?
I thought I put everything in the bag.
You lost
Made
your
those
note
copies
packet.
yesterday.
The whole thing.
Good job, man.
That's been
Yeah, can you check back there to see if you can see the originals in hole punch? It's definitely a better time than, at the end of class, right? And if you don't see it back there, I'll print out a couple, yeah, it's, yeah. So, have you looked through the entire notebook?
It's not in there.
I looked
You're
through the
having
backpack.
a
How did you
village
lose it? Did you look through both your notebooks? You sure?
I just did my
Ow.
Let me know if you don't find
no
it. Is
way.
that it?
Yeah, I think so.
Can you hole punch it real quick for him
Can.
so that he can put it straight to his notebook and never lose it?
Wait, but that's the original.
Okay.
Wait, does that include these rubrics? Ian, do you have the scoring rubrics? Or were they in the packet as well?
They were part of that package.
Okay, I'll just hole punch them.
That's for the unit, whatever. Okay,
Okay.
sake of time, we gotta keep going a little bit. So, a study was conducted to see if the number, this is to check your understanding with this. What I'm gonna do is I'm gonna give y'all 60 seconds to talk as a group, and then we'll just go over it quickly. But a study was conducted to see if the number of minutes of screen time is a good predictor of the popularity rate for Star Wars characters. And if you've never seen it, fix that, because it's fantastic. I mean, the original trilogy, ignore the sequel trilogy,
A
it
New
sucked.
Hope.
Yeah, wait, what? Like you're saying watch A New Hope?
No.
I haven't.
Or are you saying
I was
ignore
saying
it?
like I was like that's the new one. A new Hope.
No, A New Hope
That's
is
the first.
the OG. That is as original as it gets, dog. That's the fantastic one that everyone used to watch, Empire Strikes Back, the best one ever. Alright, right here though. Huh?
Thank you
No.
so much, Mr. Anderson.
Okay.
Might not be long.
After the AP exam, y'all can come in and we can watch it, but no, not tomorrow. Okay. So, actually, like, legitimately, I think in the spring, 2 of my classes are seniors, so like, I'll be done, I guess, at the beginning of whatever time. So if you want to come in and watch it then, we can.
Wait, what? When?
Oh, I'll bet I'll be there.
After, in the spring, after the AP exam, my first and third are senior classes. So you can come in first,
Yeah,
second, or
I'll be
third.
there.
Can we watch
Okay.
Twilight too?
No. Focusing on stats. Sorry, we're getting back on topic now. So, identify the explanatory and response variables. So what is the explanatory in this case, and what would be the response? So talk as a small group for 60 seconds, look at the data, what is explanatory, what is response?
Wait, you didn't say that right.
Number of minutes of screen time is
I am going to be able to do that.
popularity rate.
I'll explain how to do it soon.
Oh, yeah.
Response is actually
I was just trying to see what you're thinking.
Yeah.
Or like the popularity.
so dang.
Alright, so what are we thinking the explanatory variable is?
Screen time.
Screen time is explaining the rank, okay? How did y'all come up with that?
Because
It says screen time predicts the
So,
popularity rate.
One of the things I want us to notice, 'cause there's actually a few different ways you could have said this, but it does say the number of minutes of screen time is a good predictor. So this is predicting the popularity rank, it is explanatory. Typically, when you make your own table, do you put your explanatory variable last? No, typically your explanatory or independent goes first. It's the X, so they're just trying to be a little tricky. But did anyone else look at the graph?
yes. Yes, I looked at the graph.
Look at that graph. What's on the x-axis?
Screen time.
Oh, the screen time.
Explanatory.
And the rank is on the y-axis, okay? So remember, use your graphs, use your critical thinking, things like that. So now, I just want y'all to talk as a small group for 60 seconds. How would you describe that scatter plot?
There There is,
What do y'all think? No correlation at all, okay.
I would never like
why not?
because they're the interesting people are the ones who watched the original mythology.
How do you not find Luke Skywalker interesting?
With
I mean, Obi-Wan's definitely
He's like
more interesting.
he's like a boy. Like he's just like a what's the word I'm trying to find?
Protagonist?
Yeah, I don't like that.
Anyways.
no, there's
Okay.
potential outliers. There's
They're not my favorite.
There's no direction.
So there's nothing to say on a neutral.
Alright,
I've never read.
so, let's look at this one, okay? I've heard from pretty much every group kind of say like, man, they're either no or a weak association, okay? I will ask this, is there a line that I could kind of draw that might show a predictive ability? Madeline, you're kind of saying like this? That's not great, it's super scattered around that line, but I will point out we have a few data points that have a really low rank, that have a very low, low rank, the least favorite, low rank, high value, I guess, with very little screen time. Boba Fett, which I don't know how anyone doesn't have Boba Fett at the top of their list, but whatever. Rey, Padme, I totally get that. Emperor Palpatine, he's whatever. I got no comments. All right. So all of that to say though, okay, I would agree weak association. I wouldn't say no. I would not say no association here. Okay, so yes.
Since you said it still has a weak association by drawing the line, is it still kind of linear?
So yes. So I mean, I'll say this: it's not curved at all, is it? No. There is some association. I will point this out. If there was no association at all, the best line I could draw is a horizontal line, right? But notice there's a slight overall decrease here. Okay, so direction. What is the direction if we draw that? By the way, that's a trend line, right? You see, it's not a great trend line, but is that a line that goes through the data points? Okay, that's showing the trend. It's also called a regression line. So it's what?
Decreasing.
It's decreasing, or so there's a negative
Direction.
There's a negative direction. What else do I need to talk about?
Unusual
Duffs.
aspect.
Unusual aspects. I'll say this. We're going to talk more about that later, so hold off on that.
They're all like unusual.
Oh, so when you say in the GUF, direction, unusual aspect, form, and strength, is it like us? You absolutely need to mention everything, or if you
Yes.
don't have it, you don't.
Well,
need to mention it?
I would say like if you don't think there's any potential outliers, there are no potential outliers that I see. But come on, we got direction. It's negative.
Linear.
Okay. Is it linear? Yeah. And
Weak associated.
weak. Okay. The general order that I highly recommend, because I think it flows the best, is this. There is a weak. I should have said negative. Wait. Negative, weak, linear relationship. Okay. Or a weak negative linear relationship between screen time, not just of any characters,
Of Star Wars.
Star Wars characters, screen time, Star Wars characters, and their rank.
Rank. Like what rank though? Like negative or popular rank?
Popularity rank.
Do you read the question?
Alright? So notice,
Jeez, like.
and I will say this, overall, and you could say a linear association, a linear relationship, either of those would be fine. But you have to hit those things. Weak, right? That's my strength. Negative, that's the direction. Linear is the form. And so I've hit all those, I've hit context, I'm not gonna worry about unusual aspects yet. Yes?
So you said it was just correlations, we cannot put causation because there's no assignment treatments. If we're in order to use this by proving actual causation, is it just?
There's no way in any way, shape, or form to prove causation, because you can't have an experiment here,
Yeah,
right?
what I was asking was, can I use this to develop into experiment?
I don't, that's what I'm saying, I don't think there's any way to make an experiment out of this.
Okay.
Like, the data is already there. Hey, actually, this is a good point of order. Does anyone remember what type of observational study this would be? There's actually two types of observational studies.
A simple.
Say it again. Remember, this is a retrospective study, because aren't we looking at data that's in the past, right? So this would be retrospective. Remember, prospective is when you follow those individuals into the future, okay? That is not something that's ever been heavily tested on the test or on the AP exam, but they have added to their course of study, or course and exam description, so I need to bring that in. So it would be a retrospective study.
I think most of the studies should be retrospective unless surely they mention later they track like marshmallows.
Yeah, there's a lot of types of studies in the real world though where you do track it into the future. Oh, we got 30 seconds till we gotta go, so when we come back, this is where we'll come back to, but we're gonna have to move quickly because I gotta get at least one lesson done, hopefully 1.5, maybe 2. That'd be wild, but we're gonna try.
Maybe.
Alright.
Stars. And right.
Well, hold on to it. Give it to me tomorrow though, because I put out give you feedback before this pass. But, I'm gonna go ahead and start. I know someone went to the bathroom, we got 30 seconds, but we got stats to learn. So, here's all I want you to do. I want you to, so I should probably open that door so you get in. What is given are 6 different scatter plots along with something called the correlation R. It's also called the correlation coefficient. You may hear at some point someone call it Pearson's correlation coefficient. It's named after somebody, but for the most part, statisticians just call it the correlation coefficient. And so we're given different correlations along with their graphs. What I want you to do as a small group and write your responses on the board, actually start talking first and then one of you write on the board. What do you think that correlation R is measuring? That's it. What do you think correlation R is measuring? I'm going to give you 3 minutes to come up with analyzing those scatter plots and come up with a prediction. Yes, and then writing on the boards, yes. So at 12:53, we're going to start going over it. Someone got a little Alright, if I can grab your attention, so I want to start talking about this. So there's a couple of things I'm actually going to talk about to pull on y'all's ideas. So notice over here, we just say strength of correlation. So how strong those things are related, positive or negative as well. Now I want us to be careful at what I see over here with the kings. So there's a lot of good stuff there. How strongly the explanatory variable affects the response variable. Does anyone know what I would push back on about that statement? Now I will point out R equals 0, no correlation, love it. R equals 1, high correlation, love that. But there's an issue I have with the language of that first sentence. It is the word affects. What is the word wrong with the word affects?
It's not affecting them.
Well, we don't know.
We don't know.
We don't
for
know if
certain.
it's like causation.
We don't know causation, right? We only know
Correlation.
correlation. So what is a word we could use instead of affects there? Correlates, or is associated with, or how well it predicts, right? So do notice, right, when we're talking about that, we are talking about a correlation, not causation, right? What do we have to establish causation? Treatments and an experiment, right? How strong the relationship is. I want y'all to hold on to standard deviation or z-score because that's actually going to be really important in a little bit. because it's not normally what people think about, but it's actually a big part of this. What I do love is this language right here. Slope and strength of the trend, okay? So, what did y'all notice, because y'all talked about positive or negative as well. When you look at these correlations here, when was the correlation negative? When the scatter plot, the data was decreasing, right? When was that R, the correlation, positive? When it's overall increasing, right? So one, we need to notice, I don't think anyone wrote it this way, but what I would add on to number one is this. If R, how could I mathematically say R is positive? Like,
Negative.
If R is
if R is
Absolute
greater
value.
than 0, the direction is positive. Notice, that's the same as when the slope is positive, right?
B plus N.
If R is less than 0, the direction is negative. There we go. M is negative. Now, I also love the detail that we have from Charlie that if R is equal to 0, there's no correlation. If R is 1, complete, we would just say it is not, I will say this, if R is 1, notice we don't even have an R as 1. What do you think would have to be true for R to actually equal 1? It would have to be a perfect straight line. So if R is 1, it is a perfect line. Which, not going to happen, because what is statistics all about?
Variation.
Variation and variability. Guys, we need to remember, like, straight lines don't exist in statistics, but if it did, R would equal 1. Now, one thing I do want to point out is, I'm actually going to modify this equation just slightly. Why would I put an absolute value there?
Because it's still correlating.
Because it could be correlating even if the direction is negative, right? So, if the R is a positive one or a negative one, it's a perfect linear relationship. It's just whether it's increasing or decreasing. Surely there's something else we got to be thinking though. Some question we got to be asking ourselves at this point.
How do we get there?
How do we calculate it, you mean? We'll talk about that in a second. That's a good question. We're just talking about like what it is right now, but we will talk about how to calculate. Say it louder.
I said,
Oh, I thought you were saying a question. Come on, what else should we be asking though that y'all kind of hinted at? Well, so hold on to that. That's what I was telling Star. We're going to talk about it. Yeah, so let me ask you this question. When we talked about strength earlier, what were the 3 strengths I gave you?
Oh,
Weak, moderately strong, and strong. Okay, so thinking of those ones, what should we be asking about this R now? Ish, but like,
Which categories are
yeah, like what values of R should give us those categories, right? Like I told you, hey, we need to know how to measure that correlation, that strength, okay? So, we're going to do 2 things. One, we're going to use a cool little outlet as a class to kind of get a feeling for correlation. But 2, I will point this out. And what do you think R needs to be maybe to have a strong relationship?
More than 5. More than 0.5.
Definitely more than 0.5. So like right here, here's negative 0.66. Would you call that a strong relationship? Moderate, that might be moderately strong.
Maybe it was over 7.7.
Okay.
That's a little stronger.
That is definitely stronger, but I would still say moderately strong. I heard someone say what we would typically consider strong. So 0.8. So if 0.8, or if, let's say it this way, if R is between 0.8 and 1, that is a strong linear relationship. A strong linear correlation. Now why did I put that absolute value in there?
Because it can be negative.
Because it can be positive or negative, right? Whether it's positive or negative, if that R is between that 0.8 and that 1, it is a strong linear relationship. Okay? Where do you see some, and I will point out, that would have been a good thing to note here. Notice this is pretty strong, that 0.83. So strong, strong, what would I call these two? Weak. So what do you think separates moderately strong from weak?
Under 4? Under 4.
So 0.4 is a good guess, 0.5 though. Okay, so it's typically what we do. If 0 is less than or equal to R is less than or equal to 0.5. So if R is between 0 and 0.5, it is a weak linear relationship. I do want to point out, I keep saying linear. One thing I haven't mentioned yet that is important, R only works for linear relationships. Let me say that one more time. R only works for linear relationships.
Are we going to how to calculate the R?
Yes. I will give you a quick note though, or something to think about. How many things do we calculate by hand in this class?
Not a lot.
You know where you might be able to find something about how to calculate R? It's a resource I've already given you.
The formula sheet.
It's on that formula sheet. Now, don't stress it yet, okay? But it is on that formula sheet. Okay, so just to get a little bit of play with this, we're going to do a little applet that I pulled up. So if you ever go to staplet.com, there's a lot of good stuff there for graphing and things like that. It's called Staplet. But there's also this kind of thing where you can play around with stuff. So when I look at this right here, I'm going to give you 15 seconds as a group. I want you to predict what that R might be.
I think it's
0.46.
Okay, what are we thinking?
0.56.
0.56? I hear 0.7. 0.67, I hate you. Just rage baiting, star and me. I know, I said rage baiting. Alright, I will say this. My guess, I don't know, 0.7. That roughly. Is that a strong linear relationship?
No, it's moderate.
Is it a weak linear relationship?
No.
No. So it's got to be somewhere between 0.5 and 0.8. Now, I'm historically not phenomenal at this, but I usually get at least close. So 0. I'm going to say 7. Reveal answer. Hey! 0.722. There we go. Right? That's a moderately strong linear relationship.
This is great.
Alright.
The answer.
Okay. 15 seconds is a small group.
I got the answer.
That's right, like 0.87.
I think it's a moderate relationship.
Alright, what are we
Wait,
thinking?
no, please, give me more time.
0.77?
0.6.
0.6?
798.
Well, Andrew's like, I did not think 0.6. Is that what you're saying?
Yeah.
What were you thinking?
It doesn't matter.
You were thinking what? 0.79?
That's fine.
0.68.
Okay, let's go somewhere in between. Let's say 0.75.
She did it.
0.737.
No.
Wait, how is
How do
it?
you do that?
It's so different.
Okay.
So notice, is it still moderately strong? Like, can I draw a line and these points be pretty close to that line?
Yes.
So I would say moderately strong. Okay, next one.
Oh.
0.2, 0.19.
Okay. Alright, Sophie, what are you thinking? 0.32. I heard a lot of below that. Let's find out.
You're so smart, Sophie.
I think that's right.
Hey, that's pretty good. 0.299. Straight up, I never would have thought it'd be a 0.299. That's way higher than I would have thought. Sorry, I'm about to try to just.
0.1.
1.5.
Oh, that's pretty linear. I'm gonna go with like.
That's like moderately.
Ooh.
Wait.
Ooh.
Where's the 8?
I'm looking for, well, that's better. Alright, what are we thinking?
9.4.
8.5.
I'm thinking 9.4.
Point 9.
Point 85.
Oh, that was all the way up to a .9.
I was close.
.912.
Point 932.
Ah, finally, this is what I've been looking for.
Point.
Alright, talk, 15 seconds.
Negative.
You're revealing our answer.
Negative. Oh, thank you, Dixie.
Shut up, Ian.
Okay, Phoebe, what are y'all thinking? What?
Want to be closer to.
Okay. Charlie, what about y'all? What are you thinking?
Plus it's 0.25, but I think it's actually a little bit lower than that.
Say that one more time.
My guess is negative 0.5.
Negative 0.5, okay.
Could have done
Negative 0.048. So we're thinking at least weak to maybe moderately strong.
It's moderate, yeah.
Negative 0. Let's say 5. Let's check it.
closer to 6 actually.
Yes. Wait.
I would have said 0.55. So there you go. Negative 0.579. Okay. So all I want us to see out of this, and I want us to recognize this. Nice. This correlation is estimating, right? Or is explaining how strong the linear relationship is and whether it's positive or negative. Make sense?
Yeah.
Okay? Yes, sir.
Are we gonna have to do anything like that on the test?
Estimate?
Yeah.
No.
Okay.
I'm trying to give contextual understanding though for what this looks like and what those numbers mean though.
Okay.
Yeah, good question. All right, let's go back to the slides. Number 2. So I want you to talk about this within your small group, and then we're going to go over it in about 90 seconds.
About 67 seconds. Y'all, where is this?
I can't go with that. Did you guys put 9, 7, or 9?
Negative 0.95.
Okay. What are we thinking? Number 2.
Negative.
Positive.
Positive.
Right, if I draw a line through it, trend line. Weak, moderate, strong, very strong.
Moderate.
Moderate. What do you think the correlation might be?
0.49.
0.72.
0.48.
The answer key,
Oh wait.
0.55.
Oh.
I think. That feels low.
Yeah.
No, that seems about right.
Yeah.
Yeah, 0.55.
We did.
So, I will say this. So, it may feel really far off, but I would point out, overall, if I'm looking at the majority of data, it would look like that. So, I have these 5 data points that don't really follow that trend. You know what that's going to do to R? Cause it to go down, right? So, how closely do all the data points follow the line? Because we have a few that are so far off, that may be why the R is a 0.55. All right, number 3.
Negative.
Negative.
Strong. Very strong.
So this is where they would say very strong for sure. We would say strong linear relationship. All right, correlation.
9.7.
Negative.
I think, negative 0.97. I think that's what it was. I would, 9.7 to 9.8, somewhere in there is my guess.
Almost 6. Probably closer.
All right. Okay. So we're about to go into the next part of this, and so I'm going to kind of just walk through this a little bit with you so that we can focus on something called R squared. So we're going to take that R, and guess what we're going to do to it?
Square it.
We're going to square it. And it reveals some really, really, really important information, okay? So that's why I'm going to spend a bit of time here. It's one of the things that students don't love as much. All right, number 4. after class, the group, so this is, we're gonna use the group's Barbie bungee for 4 and 5. We're gonna go back to our candy grab for number 6 though. Okay, number 4, after class, the group measured the distance traveled for 12 rubber bands. How will adding this point affect the correlation? So think about where we would put that point. And so notice, I should have pointed out, that's the 12 rubber bands. There's that point right there. What do you think it's going to do to R?
Better?
It's gonna increase it.
It's going to increase it. It's going to make that linear relationship even what?
Stronger.
Stronger, okay? So this is going to increase the correlation R by making the relationship more what?
Strong.
Yes. What is the strength measuring though?
Oh, linear.
It's how linear it is, right? So when we say it's getting stronger, we're saying it's a more linear relationship. Okay?
Sure.
Mhm.
If it's not a linear graph, is there other values like R for each type of?
No. So you can, let me say this. R, only for linear. R squared works for anything. So that's another reason why I want to talk more about R squared in a second and explain what R squared is. Okay? So it increased the correlation R by making the relationship more linear. Now, number 5, the group accidentally typed 85 centimeters right here instead of 58. Notice it took this data point and made it here. What's that going to do to R?
Decreases.
So why is it decreasing?
Because
It's out of the line.
So decrease the correlation R. So when you say it's out of like the pattern, it's making the relationship what? Weaker.
Less linear?
Yep, is less linear because the relationship is less linear. Questions before I continue? Oh my gosh. Say again? What'd you say? Oh yeah, I am. My mind, my remotes. Okay. So, please notice they give you a template for interpreting. Oh my gosh. We're going to talk about something called interpolating, which is what I was trying to say. Interpreting the correlation R. Notice it has to be what type of relationship?
Linear.
So it's a linear relationship between the explanatory and the response is strength and direction, okay? Now, instead of using that data and there are, I think we collected some data yesterday, didn't we? Okay, so I'm actually going to have to get you to do something for me. I need you to learn how to calculate or to log in to these calculators. I know, it's tough. So, everybody hit the home button.
We did this in miscellaneous.
PTSD.
I shouldn't say that. Why do people mess with things? It's in Chinese.
No. So press the test mode.
Press the test.
Dressing.
So first thing I will say is this. So it should still be okay. In the top right, it should show a, so like if you're looking at my cursor here, if you're looking at the top right, it should show a circular little symbol. If it shows a Wi-Fi symbol, things aren't going to work. You don't have anything? Okay.
Wi-Fi symbol.
So, a Wi-Fi symbol? Okay. Do this for me then.
Oh.
Hit the home button. and go to number 5 settings. Alright, so,
Login.
well, not yet, because if you don't have that circular symbol, you can't.
Is it the one that looks like a refresh button?
So 5 settings,
Yes.
check the network number 6. Yeah, it looks like a refresh symbol. Check the network number 6. Under network, you should be able to click across and it should say Kenny 403.
Yeah.
It needs to say Kenny 403. If so, soon it should have that circular little symbol in there.
Yes.
Okay.
That's so
Wait, I have a
obvious.
Wi-Fi.
No, I redid yours.
Okay.
Okay?
Mine's going.
So yes, connect. If it doesn't say that, we should be connected. Okay, so now go back to 5 settings and go to login.
I'll just get another one.
Yeah, grab a different one. That's weird.
I'm joking.
Okay, so go to 5 settings, go to login. Your login will be the first letter of your first name and your last name. So Nathan Kenny would become N Kenny. All right, and then your password is whatever you type in right here and right now. So you are making your password. No. First letter of your first name and your last name.
Open.
So Emerson Gore would be E Gore.
One more time.
Yes.
He broke my
Ooh,
gun.
actually,
An aider.
no, don't open that yet.
Oh.
It's fine.
Wait, say that again.
Don't worry about
Okay.
No, open log.
Make it Jack Frost.
Okay, well,
I mean, I just said my password for the whole class again.
I promise we won't on
I don't care about your password, Sarah.
I don't even know what the circle's supposed to look like.
I'm not making it my first and last name.
You don't press.
No, he doesn't want to special name.
What is the circle supposed to look like?
Stat 67.
I'm steps in the bottom.
I love
Please write that down so I won't forget.
I will write it down.
Wait, what circle? What is a circle?
Mine is in
I
the
have the
screen
Wi-Fi.
goes past out and out.
Oh my god.
Alright,
Is this supposed to
hopefully you only get one file, we'll find out in a second. But you should get a Fall 2025 AP Stats candy grabbed, or Fall 2025 candy grabbed when you log in, okay?
Open.
There you go.
Open it, yeah, the Fall 2025. Okay, so open the Fall 2025 candy grab.
Wait, what's the password?
Do I want to say it?
Whatever you type right now.
Oh, that's because this is a new hat and I have not.
Yes, and you make your own password.
Stat 67. Yay.
Let me know if that one doesn't work, and then I'll try to.
Can it be like all lowercase, or does it have
It can be whatever you want.
password?
This.
This.
Try that.
Mrs. Bubro.
That's just wait a second, it should turn to the circular thing.
Mine is not my last name and first name.
There you go, now you can log in. Alright, so we should have this data pulled up. Did you not get logged in?
I don't know. What is it?
So if you go to document, browse documents, number 2, Fall 2025, and you want candy grabs. Alright, here's what I need us to do at this point, okay? So first things first, we should be on 1.3. Now it was brought to my attention, I haven't shown all the details about how to maneuver in this calculator. So I just want to point this out really quickly. If you click just literally on these at the top with your cursor, it'll allow you to move across them. Now, I have more than just 3 pages in here. So you see how there's an arrow right here? You can click on that arrow. Or, if you look right here, there's a little page to the right. So I'm going to have to hit my control button and click that, and it'll page to the right. Same thing with going backwards, okay? So lots of ways to move through these pages, okay?
Why did I use my cursor?
Yeah, so you can do control and then arrow, control and then arrow, yep. Okay, so you should be on 1.3 right now, okay? Now yesterday, we collected data that looked at the correlation between these people's heights and the amount of candy they grabbed, or the hand span and the amount of candy they grabbed. So, whenever you ask like, hey, Mr. Kenny, how do I calculate R? Guess what? By using a
You
calculator.
don't have to.
Okay? No, you do, but using a calculator. You don't have to do it by hand. So what am I gonna press?
Action.
I'm gonna go to menu. Menu does all the cool stuff. Then statistics.
Calculations.
Statistical calculations or stat calculations.
One.
Linear regression.
Yeah, I'll say we now have bivariate data. I'm not doing one variable. I'm doing two variable, but I'm specifically looking at a linear regression.
Oh yeah.
Three.
Is that MX plus B?
So mx plus b is what is traditional, but in statistics we traditionally do a plus bx. I'll explain why. It actually does not matter. What you need to be aware of is if you do a plus bx, what is this b actually in that?
The y-intercept.
Not in a plus
Yeah, the
bx.
slope.
I would say, see how it's b times x, just like it's m times x? This b is my slope, and this a is the
Y-intercept.
y-intercept. So it's the same slope-intercept form. This form is actually better because don't you really start with a y-intercept and then you add your slope? So that's what that's saying. I'm starting at whatever the y-intercept is and then repeatedly adding the slope. That's the form that I prefer. I just don't push that on students because we're not used to it. But I do a plus bx. So what is my x list?
Equal.
So let's go with height first.
Y list is your P or candy.
The y is candy.
What's not like Ian? You're so smart.
That's weird.
Y is candy.
Alright, so let's go with height for my explanatory variable. My response variable would be candy. Okay? And do not do your first result column in B. I think we have A, B, C, D filled with stuff, so probably E. So notice the first result column I do is the first column that doesn't have anything in it. And I hit enter. Ooh, that's going to delete data. Don't do that. What did I put there? Oh, okay. So let's go to G. P.S. These are calculators. You can just, yes, you have to go put the data in. Yes. It doesn't take that long though. Let's be real here. So G is what you would want to put it in. And that's actually a good thing because I forgot we want that data that's already there.
Wait, why does the letter matter?
Because we want to put it where there's nothing already there. Okay, so height.
Candy.
Candy, thank you.
Wait, you said G, right?
I would start in G.
You're G. Alright.
Okay. All right. So the relationship, and we're going to do more with this later, because I haven't really explained what this equation is yet, so don't worry about that equation. What I just want to focus on really quickly is R. So what is the correlation there? 0.66. So how would we interpret that? There was a moderately strong and positive linear relationship between a person's height and the number of candies they grabbed, right? Okay.
And do you have to state the number too? In the sentence?
It's because
Oh, because that
telling us the
indicates
strength.
moderately strong.
Yeah, that indicates moderately strong. Okay. Now, what I'm going to quickly do is actually, I'm going to go back through that, but I'm going to do handspan. And I'm going to find out which one is a better predictor. Okay, so now handspan and candy. And now we need GHI, I think. So put I as your first result column this time. We're doing handspan. We did height last time. Okay.
No way, 6'7".
Oh, no.
Yes.
Is it actually
So, which explanatory variable was a better predictor?
The
Handspan just slightly, right? Notice those correlations are essentially the same, right?
Right.
But handspan is a slightly better explanatory variable. Has a higher R. Okay? Now, yep, that's what I thought.
6.
So how would we interpret the R for candy grabs? There is
There
a
was a moderately strong
strong.
correlation between the handspan of people and the amount of candy they achieved.
And so that's how I would say, notice they give a template here. If you're like, man, Mr. Kenny, I don't want to like play with something, I want to memorize a template that gets me there every single time. The linear relationship between handspan and number of candies grabbed is moderately strong and positive. Right? So like that's how you would interpret, you would do the interpretation of that correlation R. Or you could just say there's a moderately strong linear relationship between the handspan and the number of candies a person grabs. But that's how we interpret the R. Questions about 6? That makes sense? We'll say a template's not a bad thing to go by. If someone had asked you for interpret this correlation, I can guarantee you this, Mr. Wilcox knows what he's talking about when it comes to stats. Okay. Mr. Wilcox, Luke Wilcox is the guy who did Stats Medic.
Oh.
He was like the origins of it. There was a Calc Medic as well that someone else created. They were colleagues or friends, and so they put it together to create this mathematic that goes from Algebra 1 on up. Okay, now we got to talk about something called a coefficient of determination. And that's that R squared I talked about. That's all it is. It's squaring R. But that coefficient of determination is actually telling you way more information than R is. And I don't want to just give you this template, okay? Because it loses a lot of the meaning. So I do want y'all to pay attention to this. Right here. Here is the original data for the amount of candy grabbed, right? We had a mean of 20, and we had a standard deviation of 7.3. Man, that's a lot of spread, isn't it?
Yes.
Like, guys, if we had a mean of 20, that's it, and my standard deviation is 7, like, that's a lot of spread. My maximum, I think, was only 33, wasn't it?
Right.
So there's a lot, my point is, there's a lot of spread going on in that dot plot. In fact, you can see it here, right, as a box plot or as a dot plot. So there's a lot of spread there, right? Those data points are really spread out. In fact, I think you can see this. Let me see. I don't think I've ever pointed this out before. Oh, right here. Oh, they don't show it all. So this SSX right here, this is the sum of x minus x bar squared. So when I look at like how far those data points are and I squared and I add them all up, that sum is 430. Okay, a lot of spread there. But when we talk about relating that to the handspan, isn't some of that spread at least explained by the relationship with handspan?
Yeah.
Like as people's hands get bigger, overall they grab more candies. Is that a fair statement? Okay. So some of that spread isn't random. Okay. Let me say that one more time. Some of that spread is not random. Some of that spread is explained by a person's hand or the relationship with their handspan. So the question is, how much spread is explained, and by spread I mean variability, is explained by the linear relationship with the explanatory variable.
Water is strong. Water is stronger above that level.
Well, what I'm going to show you actually how to find out what the percent is. Okay? So let me go back here really quickly. Let me see if they provide this data here. You talk about that later. Don't. Let me see if they provide it elsewhere. Should have thought through this. Sorry guys. 1 second. 2 variable. Handspan. Candy. Here we go. So, notice how much spread there was. Oh no, that doesn't give me what I need. Just kidding, ignore that. Okay. I wish I could show it a different way, but that's how I'm gonna have to do it. So, remember how, where was it? R was 0.67. You're welcome, Star. That R was 0.67, right? Okay. So what would R squared be?
Less.
It would be less. That is true because it's a decimal. So when I square it, then it will become a smaller number. But we also had it, I think, right here.
0.45-ish, I think.
0.3.
37.
It was 0.4537. Okay.
Wait. I said
So I want you to think about this. The question was how much of that variability was explained by the linear relationship with the explanatory variable. So how much of the variability in the number of candies grabbed is explained by this linear relationship? Any guesses?
45%.
45%.
Oh.
So what is R squared measuring? R squared is measuring how much of the variability, I should say, in the response variable is explained by the linear relationship with that explanatory variable. So that's what R squared is telling us. And that's what it says right here. 45% of the variation, the variability in the response and the amount of candies grabbed is explained by the linear relationship with the explanatory variable. Okay, I'm going to show a little bit. Oh, that's what I could have done. So I'm going to let you interpret it in just a second. Here's what I want you to see really quickly though. Candy, right here, right? Mean was what, 20?
Yes.
So it should be right here. Alright, so you see how I can find how far this is from here? And that's positive, and this is negative. So if I add all those positives and negative distances up, what do I get?
0.
0. Which is why, what did we do when we found our standard deviation? We square them, right? So we square them and then we add them up. So that's that SX, or SSX, is the sum of x squared, or squared, sum of squares I think is what it is. But it's sum of squares. However, when I draw a trend line in here, do I have as much spread or distance from the trend line overall? No. Like if you look at all those distances in blue versus these distances in purple, can we agree that, man, the distances in blue are less than the distances in purple?
Way less.
Way less, right? So that linear relationship has reduced that spread, okay? That's what we're saying here, is that that linear relationship has reduced my spread. By how much? By 45%. So there is this spread in the amount of candy grabbed. That's our standard deviation, and we can use that a little bit. But also, we are reducing that amount of spread. So, which, holy crap, is later than I thought. So much for 2 lessons.
Wait.
Or lesson and a half. So 45% of the variation in the candy grabbed is explained by the linear relationship, whoops, as you break my calculator, with hand span.
Are you gonna send the notes to us?
Well, I would just grab that. We will, I will start tomorrow with, these quick notes. But we actually, you have all that information there. So we'll start there, when I say start tomorrow, after the test, we'll start there tomorrow. So,
How do we log out?
you don't, I just end class.
Oh, Potters.
So, what I will do is collect from class, okay, in
No,
class.
you know what you
Wait,
need to do?
Do you want us to like the calculator too?
You don't need, well, if you need one to practice and prepare for the test
Yeah.
tomorrow, that might be a good thing to take.
Oh, that's.
Yes, how many of you all have already just taken one and had one this whole time? Because I'm missing a lot.
I know, I get them back. Oh yeah, I mean,
But you've had one?
Yeah.
I think,
yeah, I
I
had
think
one
like
yesterday.
20%.
Okay, that's fine. I just need to know how many of y'all already
I
have.
remember at one point Ian had like
Because
3
I need to get a few more.
Why are you switching?
Snitching? You could at least said, why are you lying?
See you, Raina.
Oh.
Okay,